We have a new chapter starting today, and it's very exciting because it's all about fractions, decimals, and percents. So today we started with somewhat of a paradox. If you had €1,000 in the bank, and how many days would you run out of money if you spent half of it every day? So the first day you spend €500, the second day you spend half of that, €250, the third day you spend half of that, €125, etc. And the question that your group tried to figure out is, in how many days will you run out of money? And number-wise, you will never run out of money because decimals go on infinitely. Once you get to a very small amount and you take half of that, you just keep getting more zeros in between. So mathematically and theoretically, you will never ever get to zero. However, the paradox is that once you get to something smaller than 1/100th of a euro, the bank would essentially say you don't have enough money to keep the account open. So the bank would probably close your account. So what we explored today was this idea of infinite decimals and the idea that the only way to get to zero when you multiply by a half is to multiply a half by zero. Multiplying a half by a number infinitely, the denominators just keep doubling, and that can go on infinitely. And multiplying by a half with decimals, the decimals go on infinitely. You just get smaller and smaller decimals. So that was our first paradox. And we talked about what a paradox is. It's when you have something that seems one way but is contradictory, because it can also be seen another way. So we did Zeno's paradox about why the tortoise would never ever be overtaken by Achilles. And if you want to read about that, it's on pages 130 and 131. So the big idea is that the numbers between integers are commonly represented by decimals, and that's what we started with today. So you started off by proving how 25/100ths and a fourth are the same amount. Some of you broke 100 into 4 parts and showed that 1 out of 4 is 25/100ths, and some of you wrote an equal fraction. 1 is to 4 is 25 is to 100. Some of you divided 1 by 4 and got 0.25. There are many ways to prove it. And then we talked about making sure you use your common sense in this unit, making sure you look back. You know 3/8 is less than 1, so when you change 3/8 into a decimal by division, make sure it's 3 divided by 8. If you do 8 divided by 3, you'll get 2 and 2/3. And 2 and 2/3 doesn't make sense because 3/8 is less than 1 and 2 and 2/3 is bigger than 1. And then we talked about the multiplier that will show you that 3/8 is equal to the decimal of 375 thousandths. And remember that you can represent different amounts in many ways. So 3/8 of a euro could be represented with 3/8. It could be represented with 375 thousandths. It could be represented with 37.5 cents. They're all the same amount of money. And we talked about how you can have a euro as a 1 euro coin, or 2 50-cent coins, or 5 20-cent coins, or 100 1-cent coins, and those all look different, but they're all equal amounts of money. All right, then we talked about intervals and tick marks, and make sure you see this pattern. From -5 to 5, there are 10 intervals, but there are 11 tick marks because you need one at the beginning and one at the end. So in between -5 and 5, there are 9 tick marks for 10 intervals, and then you have a tick mark at the end of that and a tick mark at the beginning of that. So I said look for the pattern. So on a number line, you'll have one more tick mark than the number of intervals, and the intervals are the distances between the tick marks. All right, on your number line, you enlarged, you magnified this number line to only show 5 3/10 to 5 4/10, and then we ended up doing a lot of work with this number line, and some of you came up to the board and showed where 5 and 365 thousandths would be, and then where would 5 and 3,655 10,000ths be. And remember, as Brody said, we can just keep adding zeros after the numbers after the decimal, and it doesn't change the value of the number. So how many numbers are between 5.3 and 5.4? Infinite. Decimals are infinite. All right, and then you had to figure out where this triple jump record was, 15 and 36/100ths of a meter. And remember, if you put a 0 after the 15 and 3/10, you see 15 and 30/100ths. Put a 0 after the 4 and 4/10, and you get 15 and 40/100ths. 15.40 is the same amount as 15.4. 15.3 is the same amount as 15.30. But if I put those zeros in, it's easier for me to find 15 and 36/100ths, because I know this is 15 and 31 hundredths, 15 and 32 hundredths, 15 and 33 hundredths, etc. And then we had a discussion about why in real life, when you're in the middle, you round up, and usually there aren't just zeros after that hundredths place. So that's the reason why it's slightly to the right of the middle, and so that's why we usually round up. And then several of you came up to the board. We compared decimals. You had to find the one that was larger and prove how you knew. So the ones places both have a 5. They're the same. But in the tenths place, 8 tenths is larger than 2 tenths. So 5 and 8 tenths is the bigger decimal. And same thing with this example. In the ones place, we have 5s. In the tenths place, we have 0s. In the hundredths place, 8 hundredths is bigger than 2 hundredths. So we can just look at the place values of the numbers. Okay, then we had 5 and 12 thousandths versus 5 and 8 thousandths. And one person came up and said 12 is bigger than 8. And another person said you can just look at it one number at a time by place value. Both have a 5, both have a 0, but in the hundredths place this is a 1 while this is a 0, which means this decimal is larger. Really good ways to look at it. And in this one, they were the same, but in the 10,000ths place, this one has a 3, and that's bigger than 1, so that entire decimal is larger. And then out of these, when you have differing decimals with different amounts of digits, one way to make it easier to look at is to have it so that fill in with zeros so that each number has the same amount of digits after the decimal. What that does is makes all of these into millions, So if I fill in these two zero, I can see that this number is 5,200 millionths, whereas this is only 5,172 millionths, and this is only 590 millionths. So that might make it easier to compare. And then for these races, you had to put them in order from the winner, the shortest time, to the slowest time. And we talked about how close these times actually are. And then I think in one class, Yasmin came up and put that on the board, and you guys gave thumbs up or thumbs down. And then when we get to negative decimals, you have to remember that when you're on the other side of 0, on the negative side, because as you move to the right, numbers get bigger, the value of the numbers are the opposite as the value on the positive side. So what I mean by that is if these numbers were positive, 8 and 7 tenths is bigger than 8 and 3 tenths. But when they're negative, those reverse. 8 and 7 tenths is further to the left. As I move to the right, I get closer to 0. So negative 8 and 3 tenths is the larger number here because it's closer to 0. And then I had you graph it on a number line to prove it. And then we set up some axes and reviewed the coordinate plane. First thing you did was graph the ordered pair 3, 4. Remember that you walk before you fly, so it's x before y. So you always begin at the origin where the two axes intersect. The first number is a 3, it's positive, so we go 3 units to the right. Second number is a positive 4, so we go up 4 units. And this point that's blue is the address for this coordinate ordered pair, 3, 4. So then we talked about where would this ordered pair be, 3.5, 4.5. Same thing, only now you have to estimate. So it's 3.5 to the right and 4.5 units up. So that green dot is this ordered pair. Where would this ordered pair be? Now, negative 3 and 2 tenths, negative 4 and 6 tenths are in quadrant 3. Remember, if the first number is negative, we go to the left. If the second number is negative, we go down. So if x is positive, it's right. If x is negative, left. If y is positive, it's up. And if y is negative, it's down. So this is the third quadrant where both are negative. And now you have to use a little estimating. I start at the origin. I go 3 units and 2 tenths of a square more, which is a fifth. And I go down 4 units and a little more than a half. So it's about right there where that blue dot is. You're obviously going to have to estimate. All right, then right before class got out, you guys had to find the biggest and the smallest and tell your reasons why. S stands for smallest, B stands for biggest, and those are correct. And then which decimal is less than the other? The circled one is less. And again, if they were positive, this would be bigger, but they're negative, so it's the opposite. So that's smaller. On the positive side, this is bigger, so on the negative side, it's smaller. And on the positive side of 0, this is bigger, so on the negative side, it's smaller. and you have a bit to practice. So make sure that that's done. Choose basic or challenge. And that's it.